Hi, I'm Laura Betz. Welcome to Goddard. Let me show you what's happening with the James Webb Space Telescope. This is the gowning room for the clean room. This is where we walk in on all of this sticky stuff that captures all the dirt on our shoes. It's like a mat of tape. It's where we come over here, we clean our shoes off. We grab our hairnet, put that on. Sit down. That's where we put our booties on. We head into the air shower. This is what it's like in the air shower, getting all the particles blown off of me. Whew! Now that I'm all clean, it's time to get gowned up. These are all sealed up to keep them extra clean. Put on my hoodie. Now it's funny because this side over here is the dirty side and this side over here is the clean side. So when I put my boots on, I have to step over here to the clean side. Make sure everything's nice and snug. All right, so we come over here. So then take some tape. Humans are the dirtiest thing that goes into the clean room. That's why we seal ourselves up in this. And this is what we call a bunny suit. So I'm going to just check myself off here, make sure everything's okay, and then we're going to head into the clean room. Welcome to the world's largest clean room. This is where we're putting together the largest space telescope ever, the James Webb Space Telescope. All of the air in this room right now comes from this wall of filters. It's about 100 feet tall, and each one of these HEPA filters lasts 50 years. The air flows from this wall all the way to this white wall over there, where there's tiny holes. This room has a higher pressure inside than in any of the rooms outside. So when they open these doors for shipments, it keeps the air clean because the air rushes out and no particles come in. Let me show you some of the James Webb stuff. This is the assembly stand for the telescope. The mirrors are going to be placed onto the back plane here. This is one of the James Webb Space Telescope mirrors. Right now it's being tested to make sure that it keeps its perfect shape. Now we're going to the mezzanine level to check out the mirrors. was a lot of stairs. Now, these are all of the mirrors for the James Webb Space Telescope. Come in these containers that keep them very, very clean. Kind of look like pods for aliens. All 18 of the James Webb Space Telescope mirrors are in this room right now, including the 3 spares. From this railing, you get another perspective of the room. If you're lucky enough to come to Goddard, you can check out what's happening in the clean room from this observation deck. All right, let's go check out the thermal vac chamber. This is our massive thermal vac chamber, where the heart of the James Webb Space Telescope is being cryogenic tested right now.
Gary.
This is a massive thermal vac chamber at Goddard. It also serves as space environment simulator. So what it does is it simulates the environment in space, and it also drops the temperatures down very low. For the heart of the James Webb Space Telescope, that's going to be negative 425 degrees Fahrenheit, or 19 degrees above absolute zero. So that's really cold, and the reason why we have to test it at such low temperatures is because sometimes at very low temperatures, the properties of materials change. So let's check out a demo that my friend Amber did to show what happens when things get really cold.
Why will the Webb telescope have to face such harsh temperatures in space?
So because the Webb telescope is an infrared telescope, infrared light is basically heat radiation. And so the detectors, the cameras themselves have to remain very, very cold in order for the telescope to be able to detect these faint infrared signals from the distant universe. And one of the challenges to building a telescope like this is to build the telescope itself here on Earth in normal temperatures and then launch it into deep space. And so just to demonstrate this, here I have some surgical tubing, which you can see is very flexible, bendy, and normal temperatures here. But if I dip it down into liquid nitrogen, you're going to see how the structure of the material changes. And so when we build these telescopes here on Earth, we have to be really smart about what we build them with and how we build them, and have to do lots of tests to make sure they will withstand the cold of deep space. And so you see here how the material completely changes. The structure of it just completely changes when it gets very, very cold. And here at Goddard, we have undergone a crucial milestone, a test of the structural heart of the Webb telescope. This test has shown that it's going to withstand the cold of deep space.
Hey, thanks for coming out, and check out our website.